Hi, this is Sir Imman, and today we're going to learn about the basic concepts of electricity. Today, we will be discussing not only about electricity, but also atom, electric charge, electric current, voltage, and resistance. We all know that electricity is everywhere. You can find it in our phones or smartphones, in our laptops, in our light bulbs. Basically, you can find electricity everywhere, even to our cars right now. You can find electric cars that do not use gasoline or diesel. Instead, they rely on electricity only. Now, we can also find electricity in nature. You can see lightning during thunderstorms and even inside our body. In our neurons, we have the synapse, and there you can find electricity. So basically, what I'm trying to say is electricity can be found everywhere. But what is electricity? To understand atom, we need to understand the history of atomic structure. Now, the search for the atom began as a philosophical question. It was the natural philosophers of ancient Greece that began the search for the atom by asking questions, and as early as 400 BC, some Greek philosophers proposed that matter is made of indivisible building blocks known as atomos. To these early Greeks, matter could not be continuously broken down and divided indefinitely. Rather, there was a basic unit or building block that was indivisible and foundational to its structure. This indivisible building block of which all matter was composed became known as the atom. Now, the early Greeks were simply philosophers. They did not perform experiments to test their theories. In fact, science as an experimental discipline did not emerge as a credible and popular practice until sometime during the 1600s. So if you take a look at history, basically science was not popular. So the search for the atom remained in a philosophical inquiry for a couple of millennia. From the 1600s to the present century, the search for the atom became an experimental pursuit. It's because of several notable scientists. Among them are Robert Boyle, John Dalton, J.J. Thomson, Ernest Rutherford, and Niels Bohr. Now, we don't have time to explain further or to tell you what are the contributions of those scientists. However, I just can give you the summary of their contributions and how it relates to electricity. So, according to them, all material objects are composed of atoms. There are different kinds of atoms known as elements, and these elements can combine to form compounds. Different compounds have distinctly different properties. Material objects are composed of atoms and molecules. So basically, each element, each compound has their own electrical property, and if you can recall in your chemistry class, you have their electrical conductivity in your periodic table. They also found out that an atom consists of a nucleus and a vast region of space outside the nucleus. So, electrons are present in the region of space outside the nucleus. So basically, an atom is just an empty space, except that there is a tiny region wherein you can find the nucleus, and it's the center of the atom. Now, electrons are negatively charged and weakly bound to the atom. Electrons are often removed from and added to an atom by normal everyday occurrences. The nucleus of the atom contains positively charged protons and neutral neutrons. So these protons and neutrons are not removable by usual everyday methods. To summarize our subatomic particles, we have the proton, neutron, and electron. Now, proton can be found inside the nucleus together with the neutron. Both of them are tightly bound together. The proton has a positive charge, whereas the neutron has no charge at all. The proton and neutron, if you compare it with electron, are quite massive, meaning the mass of the atom is mostly found in the proton and neutron, whereas the electron can be found outside the nucleus. And weakly bound, meaning they can be easily removed from the atom, and they are negatively charged, and of course, not very massive. Now that we know the basic structure of an atom, we can now answer what is electricity, or we can go now to define what is electricity. Now, electricity is a form of energy resulting from the existence of charged particles such as electrons or protons, either statically as an accumulation of charge or dynamically as a current. So that's why I explained to you earlier what is an electron and what is a proton, and especially what are their charges. Now, since we know that electrons are weakly bound together, or they are weakly bound in the nucleus, we know that the atom's electrons aren't all forever bound to the atom, meaning walang forever sa electron. Now, the electron on the outer orbit of the atom are called as valence electrons. And with enough outside force, a valence electron can escape the orbit of the atom and become free, and thus we call them free electrons. Now, free electrons allow us to move charge or charges, which is what electricity is all about. And speaking of charge, as I've mentioned in the beginning of this lesson, that electricity is defined as the flow of electric charge, or a form of energy resulting from the existence of charged particles. Now, what do you mean when I say charge? We know that electron is negatively charged and proton is positively charged. Now, charge is just a property of matter, just like mass, volume, or density. And charge is measurable. Just as you can quantify how much mass you have in something, you can measure how much charge an atom has or something has. So the key concept with charge is that it can come in two types. You have, of course, positive and negative. In order to move charge, we need charge carriers. And that's where our knowledge of atomic particles, specifically electrons and protons, comes in handy. Now, electrons always carry negative charge, while protons always carry positive charge, or are always positively charged. Both electrons and protons carry the same amount of charge, just a different type. As you can see, we have here an example atom. We have here the lithium atom. It has 3 protons and 3 electrons. The charge of electrons and protons is important. It's because it provides us the means to exert a force on them. That force is called as electrostatic force. Now, electrostatic force, also called as the Coulomb's law, is a force that operates between charges. States that charges of the same type repel each other, while charges of the opposite type are attracted together. That's why we have a saying that opposites attract and likes repel. If both positive charge or positively charged atoms will come in contact with each other, they will repel each other. The same goes with the negatively charged particles, or if 2 electrons will come in contact with each other, they will repel each other. However, if a proton and an electron will come in contact with each other, they will attract. So the amount of force acting on 2 charges depends on how far they are from each other. So the closer you are, the greater is the force of attraction. The farther they are away, the lesser the force of attraction, or the electrostatic force becomes. Thanks to this electrostatic force, electrons will push away other electrons and be attracted to protons because opposites attract. This force is part of the glue that holds atoms together, but it's also the tool we need to make electrons and charges flow. Now, how do we make charges flow? Now, we now have all the tools to make charges flow. We have the electrons in atoms that can act as our charge carrier. It's because every electron carries a negative charge. If we can free an electron from an atom and force it to move, we can create electricity. So consider the atomic model of a copper atom. Now, one of the preferred elemental sources for charge flow. Now, basically, copper is very common, especially in our household wires. So copper is quite cheap, that's why we use copper. Ideally, gold is one of the best conductors. But since gold is not cheap, we use copper. In its balanced state, copper has 29 protons in its nucleus and an equal number of electrons orbiting around it. Now, electrons orbit at varying distances from the nucleus of the atom. So, electrons closer to the nucleus feel a much stronger attraction to the center than those in distant orbits. So, the outermost electrons of an atom are called valence electrons. These require the least amount of force to be freed from an atom. As you can see in the picture, you have there one valence electron. So this is a copper atom diagram in which 29 protons in the nucleus is surrounded by bands of circling electrons. Electrons closer to the nucleus are hard to remove, while the valence or the outer ring electron requires relatively little energy to be ejected from the atom. That's why that lonely valence electron can be easily removed. Now, using electrostatic force on that valence electron, either pushing it with another negative charge or attracting it with a positive charge, we can eject the electron from orbit around the atom, creating a free electron. Now, since we're able to eject that valence electron quite easily, we should consider a copper wire. Imagine a copper wire filled with copper atoms. As our free electron is floating in space between atoms, it's pulled by surrounding charges in that space. In this chaos, the free electron eventually finds a new atom to latch onto. In doing so, the negative charge of that electron ejects another valence electron, since like repels each other. As you can see there, as in a very simplified model of charges flowing through atoms to make a current, you can see there that when an electron enters, another one exits. So in this chaos, the free electron eventually finds a new atom to latch onto. In doing so, the negative charge of that electron ejects another valence electron from the atom. Now, a new electron is drifting through free space to do the same thing. So this chain effect can continue on and on to create a flow of electrons called electric current. So as you can see there, you have a simplified model of charges flowing through the atoms to make a current. Now, when we begin to explore the world of electricity and electronics, it is vital to start by understanding the basics of voltage, current, and resistance. I know I have discussed a small amount about current, but these three are the basic building blocks required to manipulate and utilize electricity. At first, these concepts can be very difficult to understand because we cannot see them. One cannot see with the naked eye the energy flowing through a wire or voltage of a battery sitting on a table. Even the lightning in the sky, while visible, is not truly the energy exchange happening from the clouds to the earth, but it is just a reaction in the air to the energy passing through it. In order to detect this energy transfer, we must use measurement tools such as multimeters, spectrum analyzers, and others to visualize what is happening with the charge in a system. Electrons create charge which we can harness to do work. Your light bulb, your stereo, your phone, and etc. are all harnessing the movement of electrons in order to do work. They all operate using the same basic power source, the movement of electrons. So the three basic principles of electricity are voltage, current, and resistance. So voltage is the difference in charge between 2 points, while current is the rate at which charge is flowing. Resistance is a material's tendency to resist the flow of charge, or resistance is a material's tendency to resist the flow of current. So when we talk about these values, we're really describing the movement of charge, and thus the behavior of electrons. So what is voltage? Now, we define voltage as the amount of potential energy between 2 points on a circuit. Now, one point has more charge than the other. Now, this difference in charge between the 2 points is called as voltage. It is measured in volts, which technically is the potential difference between 2 points that will impart 1 joule of energy per coulomb of charge that passes through it. Don't panic if this makes no sense. All will be explained later. Now, the unit volt is named after the Italian physicist Alessandro Volta, who invented what is considered the first chemical battery. Now, voltage is represented in equations and schematics by the letter or the symbol V. Now, when describing voltage, current, and resistance, a common analogy is a water tank. In this analogy, charge is represented by the water amount, voltage is represented by the water pressure, and current is represented by the water flow. So for this analogy, always remember, water is equal to charge, pressure is equal to voltage, flow is equal to current. Now let's consider a water tank of a certain height above ground. At the bottom of this tank, there is a hose. As you can see there in the illustration, you have there a water tank filled with water. Now, the pressure at the end of the hose can represent voltage. As you can see, the water is directed or the water is flowing down. The water in the tank represents charge. The more water in the tank, the higher the charge is, and the more pressure is measured at the end of the hose. If we drain our tank a certain amount, the pressure created at the end of the hose goes down. So we can think of this as decreasing voltage. Like a flashlight gets dimmer as the batteries run down. So there is also a decrease in the amount of water that will flow through the hose. So less pressure means less water flowing, which brings us to current. We can think of the amount of water flowing through the hose from the tank as current. The higher the pressure, the higher the flow, and vice versa. With water, we would measure the volume of the water flowing through the hose over a certain period of time. But with electricity, we measure the amount of charge flowing through the circuit over a period of time. So just in case you are confused, again, let's go back. Water is equal to charge, pressure is equal to voltage, and flow is equal to current. Current is measured in amperes, usually referred to as amps for short. An ampere is defined as electrons per second passing through a point in a circuit. So amps are represented in equations by the letter I. Now let's say we have two tanks, each with the hose coming from the bottom. Each tank has the same amount of water, but the hose on one tank is narrower than the hose on the other. Now we measure the same amount of pressure at the end of either hose, but when the water begins to flow, the flow rate of the water in the tank with the narrower hose will be less than the flow rate of the water in the tank with the wider hose. In electrical terms, the current through the narrow hose is less than the current through the wider hose. If we want the flow to be the same through both hoses, we want to increase the amount of water, or in electrical terms, charge in the tank with the narrower hose. So as you can see in the illustration, we increase the amount of water in the tank with the narrow hose as compared to with the tank that has a wider hose. Now this increases the pressure or voltage at the end of the narrower hose, pushing more water through the tank. This is analogous to an increase in voltage that causes an increase in current. Now we're starting to see the relationship between voltage and current. But there is a third factor to be considered here, the width of the hose. In this analogy, the width of the hose is the resistance. This means we need to add another term to our model. Water is equal to charge measured in coulombs. Pressure is the voltage measured in volts. Flow is the current measured in amperes or amps for short. And last is the hose width. Now hose width is equal to the resistance. Now let's consider again our two water tanks with one narrow pipe and one with a wider pipe. Now it stands to reason that we can't fit as much water volume through a narrow pipe than a wider one at the same pressure. This is what we call as resistance. The narrow pipe resists the flow of water through it even though the water is at the same pressure as the tank with the wider pipe. So as you can see in the illustration, you have there a pipe which has less resistance because of its greater width. You have there a pipe which has more resistance because you can see there in the middle, it has a lesser width. So that's all for today. I hope you have learned something about electricity. So see you next time.